A dishwasher and a venthood should not be wired into a small appliance branch circuit. Small appliance branch circuits, commonly found in kitchens, are typically 20-amp circuits wired with 12 American wire gauge wire. These circuits are designed to supply power to small, portable appliances such as toasters, coffee makers, and blenders. Dishwashers and venthoods, on the other hand, are considered fixed appliances that often have significantly higher power demands. Connecting a dishwasher or venthood to a small appliance branch circuit can easily overload the circuit. Overloading a circuit occurs when the total current draw of all connected appliances exceeds the circuit's ampacity, which is its current carrying capacity. When a circuit is overloaded, the circuit breaker trips to interrupt the flow of electricity and prevent overheating of the wires. Repeatedly tripping a circuit breaker is a nuisance and a sign of a potentially dangerous situation. Continued overloading can damage the wiring insulation, leading to short circuits and potentially fires. The National Electrical Code, or NEC, provides guidelines for the proper wiring and protection of electrical circuits. The NEC requires that dishwashers and venthoods be supplied by dedicated circuits. A dedicated circuit is a circuit that serves only one appliance. This ensures that the appliance has sufficient power and that the circuit is not overloaded by other appliances. The size of the dedicated circuit for a dishwasher or venthood depends on the appliance's power requirements, which are specified on the appliance's nameplate. The nameplate typically indicates the voltage, amperage, and wattage of the appliance. The circuit breaker for a dedicated circuit should be sized according to the appliance's amperage rating. For example, if a dishwasher has an amperage rating of 10 amps, the dedicated circuit should have a 15 amp or 20 amp circuit breaker. The wire gauge for a dedicated circuit should be sized according to the circuit's ampacity. For a 15 amp circuit, 14 American wire gauge wire is typically used. For a 20 amp circuit, 12 American wire gauge wire is typically used. In addition to the NEC requirements, local electrical codes may also have specific requirements for the wiring of dishwashers and venthood. It is important to consult with a qualified electrician to ensure that the wiring is done in accordance with all applicable codes. When installing a dedicated circuit for a dishwasher or venthood, several factors should be considered. Firstly, the location of the appliance should be determined. This will help to determine the length of wire needed for the circuit. Secondly, the existing electrical panel should be inspected to ensure that there is sufficient capacity to add a new circuit. If the electrical panel is full, a new subpanel may need to be installed. Thirdly, the wiring should be installed in accordance with the NEC and local electrical codes. This includes using the correct wire gauge, properly grounding the circuit, and protecting the wiring from physical damage. It is also important to use the correct type of electrical box for the appliance. Metal boxes are typically used for dishwashers and venthoods because they provide better grounding. When connecting the appliance to the circuit, use the correct type of wiring connectors. Wire nuts are typically used to connect the wires together. Make sure that the wire nuts are properly tightened to ensure a secure connection. After the wiring is complete, test the circuit to ensure that it is working properly. Use a voltmeter to check the voltage of the appliance. The voltage should be within the range specified on the appliance's nameplate. Use an ammeter to check the current draw of the appliance. The current draw should not exceed the circuit's ampacity. If the voltage or current draw is not within the specified range, there may be a problem with the wiring. Consult with a qualified electrician to troubleshoot the problem. In summary, a dishwasher and a venthood should not be wired into a small appliance branch circuit. These appliances require dedicated circuits to ensure safe and reliable operation. The size of the dedicated circuit depends on the appliance's power requirements. The wiring should be installed in accordance with the NEC and local electrical codes. Consult with a qualified electrician to ensure that the wiring is done properly. A small appliance branch circuit serves kitchen, pantry, breakfast room, dining room, and similar area receptacles. These circuits are typically 20 amp circuits, using 12 American wire gauge copper conductors. These circuits are intended to serve small appliances that are easily portable. This includes items such as a toaster, blender, coffee maker, or other device that is cord and plug connected. A dishwasher and vent hood are considered fixed appliances. They are intended to be permanently connected to the electrical system. These devices are not designed to be plugged into a standard receptacle. The NEC requires these types of appliances to be supplied by an individual branch circuit. This ensures that the appliance has sufficient power and that the circuit is not overloaded by other appliances. The required ampacity of the individual branch circuit is determined by the nameplate rating of the appliance. The nameplate provides information about the voltage, amperage, and wattage requirements of the appliance. The circuit breaker protecting the circuit must be sized appropriately for the load. It is important to consider the inrush current of the appliance when selecting the appropriate size circuit breaker. The inrush current is the surge of current that occurs when the appliance is first turned on. If the circuit breaker is not sized appropriately, it may trip when the appliance is turned on. The conductor supplying the appliance must also be sized appropriately for the load. The size of the conductors is determined by the ampacity of the circuit. The ampacity of a conductor is the maximum amount of current that the conductor can safely carry. The NEC provides tables that specify the ampacity of different types of conductors. The conductors must be protected from overcurrent by the circuit breaker. This protection ensures that the conductors will not overheat and cause a fire. It is also important to properly ground the appliance. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock. The grounding conductor must be sized appropriately for the circuit. The NEC provides tables that specify the size of the grounding conductor. In addition to the NEC requirements, local electrical codes may also have specific requirements for the wiring of dishwashers and venthoods. It is important to consult with a qualified electrician to ensure that the wiring is done in accordance with all applicable codes. A qualified electrician will have the knowledge and experience to properly size the circuit breaker, conductors, and grounding conductor. They will also be able to ensure that the wiring is done in accordance with all applicable codes. Attempting to wire a dishwasher or venthood into a small appliance branch circuit can be dangerous. It can overload the circuit, which can lead to a fire. It can also damage the appliance. It is always best to consult with a qualified electrician to ensure that the wiring is done properly. Electrical work should only be performed by qualified individuals who understand the risks involved and are trained to mitigate those risks. It is vital to comply with the NEC and all local regulations to ensure the safety and proper operation of electrical systems. Overloading circuits can create potential hazards such as overheating, which could ignite nearby combustible materials. The NEC provides guidelines and requirements for circuit sizing, overcurrent protection, and conductor selection to prevent overloading and ensure safety. Dedicated circuits offer several advantages over shared circuits, including reduced risk of overloading, improved appliance performance, and minimized interference with other appliances. The use of appropriate wiring methods, such as conduit or cable, further enhances the safety and durability of electrical installations. Regular inspections and maintenance of electrical systems can help identify potential problems early and prevent costly repairs or hazardous conditions. When working with electrical systems, it is essential to use appropriate personal protective equipment, such as insulated gloves and safety glasses, to minimize the risk of electric shock or arc flash. Proper grounding is critical for electrical safety, as it provides a low impedance path for fault current to flow back to the source, reducing the risk of electric shock. The NEC specifies the requirements for grounding electrical systems, including the size and type of grounding conductors. Arc fault circuit interrupters, or size, provide additional protection against electrical fires by detecting arc faults, which are unintentional electrical discharges that can ignite nearby combustible materials. Size are required in many areas of the home, including bedrooms and living rooms. Ground fault circuit interrupters, or GFCIs, provide protection against electric shock by detecting ground faults, which are unintentional electrical paths between a live conductor and ground. GFCIs are required in areas where there is a high risk of water exposure, such as bathrooms and kitchens. Surge protective devices, or SPDs, protect electronic equipment from voltage surges, which are temporary increases in voltage that can damage or destroy sensitive electronics. SPD are available in various forms, including whole house surge protectors and plug-in surge protectors. Electrical safety is a shared responsibility, and everyone can play a role in preventing electrical accidents by following safe practices and reporting any potential hazards. By understanding the risks associated with electricity and taking appropriate precautions, it is possible to create a safe and reliable electrical environment for homes and businesses. Wiring a dishwasher and vent hood to a small appliance circuit is a code violation.